Okay, welcome everybody. This is now lecture 28, if you can believe it or not. This is our second class on classes. If you missed Friday's lecture for any reason, I highly recommend you go back and watch it. I'm going to do a fair bit of recap today on what we covered, so if you get a little bit lost, go back to Friday. 4% of the class has done the homework so far, so I'm feeling you might not know exactly what's going on just yet. So if you missed Friday, go back, watch the video. We will be doing classes for a couple more lectures yet. These are super, super important. Okay, today's agenda, like I said, we'll do a little in-depth recap. We're going to focus a little bit on attributes and methods specifically. And then all those other sub-chapters I kind of weave in and out throughout the last lecture and this lecture. Okay, so recap. We defined, or I showed you what the syntax was for a class. And we already know a whole bunch of classes. We know lists, we know dictionaries, we know strings, right? We know a whole bunch. We looked at image when we finalized the files chapter. There's a whole bunch of classes. What is the syntax for a class? Well, it's the keyword class and then the name of the class that you're creating. And we've been using two metaphors to discuss classes. One is this video game RPG where we have characters, and another one is a menuing system. And I'm intentionally giving us two different metaphors in addition to whatever Zybooks does, just so you can start getting comfortable with using these everywhere in all different domains. So when I create a class looks very similar to a function. You have a doc string as the first part of it. So our classes have doc strings in addition to our functions. Here, I guess I was bad. I didn't put a doc string on my constructor, but I should have. As a reminder, the underscore underscore init underscore underscore function or method is something very, very special and specific. It's called a constructor. It's so important, in fact, that this first parameter, self, the interpreter gives you that. You never have to pass self in when we're instantiating a class. And we'll look at that in a minute. There's no magic here to what this is. This method is really just a function. So I can pass in parameters to my function. They could have default values. I could use args. I could use quarks. Right? This special self, though, when I want to store or do something with this parameter, more specifically this attribute, I have to say self dot and whatever it is. Notice this attribute here doesn't have to be the same as the parameter name. It can be different. Normally, they're the same. Finally, we can have our own methods, which is just a function. So here I have a method called introduce self, which will print that out. So that's how we define a class. What we looked at previously, that was like how we defined functions. And we next looked at how we called functions, right? Well, this is how we call or how we instantiate a class. So if I want to create a class, I have a bunch of variables here, one called Woody, one called Picky, and I say equals character. So notice here, that character, and we'll look at it again inside Python Tutor, that call to character open parentheses is actually calling init, right? It just makes the code a little bit neater that you don't actually have to say like character dot underscore underscore init underscore underscore. Right? You just simply say the name of my class and then whatever parameters. You don't have to have parameters. Not all classes need them. Okay, I'm going to jump this right over to Python Tutor, right? Because same thing. What do we have here? So I've defined a class up here. And again, reminder, just like with our functions, we don't really want to do that inside the main block. We want to do it out here kind of in that global scope. So here, I'm defining a character class. When the interpreter sees that, it just skips over all of that. It just says, I'm going to make notes that there's something called character, and I'm going to point at this character class when I need it. So inside the main here then, I'm going to instantiate a character named Dan, and I'm going to pass in the arguments Dan, 10, and 10. The flow of execution will go up to the init function, the constructor. And then what's going to happen, you'll see here the global scope instantiated this init thing. And now I'm starting to build out my character instance. Okay. So pay attention to some of these words. You're going to get burned in like later semesters. Dr. Bryan is particularly keen on this, being very precise with your terminology. So do you remember how I talked about arguments versus parameters? This is another part of that. You might be tempted to call this a class and call this an instance. You have to get that right. The class, there's only one of them. The instance, right, there's going to be many of them. So here, in this case, I'm creating an instance that's Dan. So I'm a character in this video game. Similarly, Roy is a character in this video game. So if you see this, I didn't create any new classes, right? There's only one class called character, but there's multiple instances of us. When I want to access those attributes on that instance, I do something like dan.name, dan.strength, roy.name, roy.strength. And what that will do is when I print something out to the screen, it will say dan.name has strength 10. When I want to call a function, again, let's not forget this. Functions, methods, it's always the name, open parentheses. And then you pass in whatever parameters or arguments that needs. So here, I'm going to say Dan is about to help Roy. Well, what does that mean in our video game? In our game here, we basically say everybody has a certain level of strength. And if I'm going to help Roy, I'm going to decrease my strength and we're going to increase Roy's strength. So if you look over here, my instance, right? I started out with 10 and I decremented it by 4. So I got 6. Roy had strength 1. I incremented it by 4. His strength is now 5. When I exit that method, notice my attributes are appropriately updated. Okay. So that's the first metaphor that we looked at, this character. The second metaphor we looked at, the one that I have here in EdStem, is building out a menuing system. So where did we get to last time? Last time we got up to about here. We created a class called menu item to represent something that lives on a menu. This should be available if you go to assignments in Blackboard, so feel free to code along. If you get a little lost, you don't want to code along, the solution is here for what we're going to go through. So I have a menu item, and it has a name and a price. So in this particular case, this is pretty simple. Let me get this thing out of the way. I created a class called menu item, and then I instantiated it here. It's a taco, and I printed it out. So I said, my menu item, taco, is $4.50. Recall, I can do this, but at this point in time, you just get some garbage, right? You get like menu item, object that, blah, 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 right? Not very useful. We'll see a little bit later on how to make that better. Okay. So let's go to the next step in our little contrived example here. Multiple instances. Create a few instances of these things. So again, just to drive home the point, right? I have a single class and I have multiple instances. So I can have a taco. Can have a hot dog. Let's say I have a salad. This is menu item 1, menu item 2, menu item 3. Now let's say hot dogs are $6.50. Let's say salads are super expensive. So when I run this out, taco, hot dog, salad, and as we looked at, I can do comma, do menu item dot price, whatever. Let's move it on down, make it a little bit more complex. Enhance the menu item. Enhance menu item so we can list the ingredients and give warnings about allergies or nuts. Okay. So what am I always fond of doing? Cut and pasting. Let's copy this menu item class. And now I'm going to pass in my ingredients. The contains nuts thing, I'm going to sort of make a claim that maybe most foods we don't have to specify. So I'm going to give this a default parameter. I'm going to say false. Here, I have an instance attribute. So I'm going to say self.ingredients is this parameter. And self.contains nuts is that argument that I was passed in. Now, if we take these things up here, okay, let's see here. Menu item missing one required argument, ingredients, right? Because we just made that a new.
You got the R in ingredients.
Thanks.
At the bottom of the table.
It's still going to give me the same error though, because I'm not passing in the argument there. So all I have to do now, just as a placeholder, right? Let me just put in an empty list. Let me just be lazy with my menu. Right. Oops. And let's say maybe my salad has nuts in it, right? Oops. I gotta get these in the right order too. Pardon, that's important. So there's my ingredients. Here are my ingredients here. Here are my ingredients. And let's say this is a salad that contains nuts, so I'll say true. So I have a taco, I have a hot dog, I have a salad. Nothing really changed here, right? If I wanted to, though, I could start, printing out those other attributes now. So, like I say, menu item 3 dot contains nuts, right? And that will tell me it's true. Okay. Next example, incorporate what we learned previously, build a nice menu. Write a print menu function that takes a title and a list of menu items. Okay, so let's go back to our menu item and a couple of our items here. And let's just baby step into this. Let's just copy this code. You know what? Looks like I gave myself a little hint here. I have my main method here. That's a nice built out menu items. There's a taco, there's a hot dog, there's PB&J. PB&J in this case has nuts. Cool. And I have a list of menu items. All right. Any syntax errors? Nope. Everything looks good. Now, I'm going to create that function. I'm not going to scope it. I'm not going to put it inside that class. There's nothing that says everything has to be inside a class. So I can still say something like print menu. I said I want to take a title, and I want to take a list of items, something like that. So we want to get in this practice of stubbing. So I'm going to say here, prints the list of items. I'm just going to say pass. And let me call that function. So it's just a function. It has nothing to do with the class. This is sort of what we learned, I don't know, last week, 2 weeks ago. So let's say this is the lunch menu. I run that. Okay, nothing seems to have broken. So maybe here I want to say something nice like print. Let's print that title. Let's do something like Let's put some stars on either side of it such that this thing is at least 20 characters wide. So let's take a baby step, see what that does. Cool, created me a lunch menu. I want to make that a little nicer. Maybe I'll say 30. Cool, pretty nice looking menu. Now, let me go through these. 4 items in list items. Print. Use my format string again. Item.name. Something like this. I'm just taking a baby step. Oops, got something wrong here. Why? Because it's called items here. Okay, better. Again, I'm trying to just building on stuff we already know here, right? So item.price. And let's make this formatted nicely. Let's put a $sign here. Let's put comma .02F. Make it look like money. Tacos, hot dogs, peanut butter and jelly. Cool. This is coming along pretty nice. What about that is nuts thing that we just added here, right? So maybe I'll do an allergy indicator. I'll say allergy equals some empty string. If item dot contains nuts, say allergy equals, let's put a little asterisk. We often see that on menus. Else allergy equals the empty string. And let's take this nice thing here, put that flag in. Outside of the loop, let's just decode this for people. Nuts. Cool. Now we have a nice menu. We're being respectful of people with allergies. Coming together pretty good. One little shortcut. I know I approached some people who were using this. They didn't know what it was. There is a shortcut when you want to do something like this, right? You can inline all of that. You can say allergy equals star if item contains nuts. Else, empty string. Lot cleaner, right? So you can start using that if you want. I know, like I said, a lot of people were using that and had no clue how to do it. A lot of people were using list comprehension. You can do the same thing with for loops, not knowing what it was. But if you know what that is, feel free to have at it. Okay, so what's the next part here? How about another class? So what I want to do here is sort of make the point, let's see, instead of just having this function print menu, what if I have multiple menus? So I think we're kind of dealing with like a lunch menu here. But what if we're dealing with a lunch menu, a dinner menu, a breakfast menu, a special menu? I don't know. So we want to reuse now the menu concept over and over again. Well, what I would do is say, right, I'm going to create a new class. Call that class menu. And I'm going to say collection of menu items. So I have my doc string. Let's just do that. What happens? Okay, nothing. Cool. Let's give it a constructor. Let's give the menu a name. Okay. Pass. Okay, so far I haven't broken anything. Let me see if I can instantiate that. Say my menu equals menu. And what do we say? It takes a title. We'll call it lunch. Okay, nothing broke so far. Now, I want to move this function inside my class. So in addition to indexing, there's a couple other things I have to do here. Because I just made this function a method, every method has to have self. So the interpreter knows to pass that in. So I have to add that self thing here, right? Let's change this up a little bit. Maybe I'll say, self.title equals name, whatever I passed in there. Now I no longer need this here, right? Maybe I want to move this into my constructor. Let's move that into the constructor. And I could say That's my list items. Okay. So now it's a lot simpler. Only difference is this thing, notice it's not scoped here. I don't see list items anywhere at this level of indentation. So I have to say self.list items. Same thing with this title. This thing isn't scoped anymore. So I have to say self.title. Okay. All right. So now I think we can do this thing. Run our code. Whoops. This requires 2 parameters. Let's pass in these menu items. Comma. All right, didn't do anything. Why? Because now I need to call my function, or more specifically, my method. Menu.print menu. Et voila. Now, again, what's the value of that, right? The value of that is, now what if I want to have multiple menus, right? All that print code is up in one, one central place. So maybe down here, we're going to have menu item, let's just do 2. Let's just do menu items 4 and 5. And we're going to have eggs. We have pancakes. I'm going to be lazy. Not going to list out my ingredients for this. Let's say for whatever reason, my pancakes have nuts in them. Keep the random prices here. Menu item 4, menu item 5 in this particular list. In fact, I can even be, I don't need that variable. I could just sneak that right in here. Call this my breakfast menu. Okay. Now I have 2 menus. I have a lunch menu, I have a breakfast menu, right? And I can just continue to build on it like that, right? So pay attention to some things I did in there, doing the pass, doing the print, doing a step, running the code, doing a step, running the code. Okay. Okay. I can find my window here. So I mentioned it several times in that, the concept of an attribute. So I'm going to build on that now. So we looked at those attributes, said Woody had a strength, a name, a defense score, stuff like that. But I was very intentional using an adjective there called instance attributes. Those are attributes of specifically Woody, right? And look at this several times here. When I'm inside of the class, I have to say self dot whatever the attribute name is when I'm assigning or accessing it. But when I'm outside of the class, I want to say like Woody dot name, or I want to say menu item dot name or price or whatever it is, right? Up until now, these are just instance attributes. And so remember, when I say instance attributes, well, we should think instance of a class. So these were my instances. So variable name in this case is Woody, right? All right. Just another example, looking at it here, right? Self.help, instance, name, instance, instance, instance. I'm inside of my class, I do self.dot. I'm outside of my class, I do variable name dot. Right? So this is the new stuff now. This is class attributes. So remember, when I say class attributes or class definition, these are attributes that are shared by every character. They're attributes that are shared by every menu item. And the way I access these is instead of using self, I use the name of the class. So I say character.attribute when I'm inside or actually outside my class. This is a little confusing, so we'll just look at it specifically here. So here, I'm creating a class level attribute called birthplace. So in our video game scenario here, everybody lives in the kingdom of Asgardia, right? Nobody can live anywhere else. Nobody was born anywhere else initially. So that is a class level attribute. I don't have to set it when I instantiate Woody or Picky. In fact, I can't. There's no way for me to do that. However, I can say Woody.birthplace, and that will give me that kingdom. I could say character.birthplace. That gives me the same thing as well. I don't really like this, but Python allows you to change these. In other languages, if this was sort of like a final, anybody ever heard the term final variable, you wouldn't be able to change. But here you can. So I want to look at that in action rather than look at this. So same thing here. Here I have a character. It's the same character we looked at before, but now I created this class level attribute birthplace. So when the interpreter gets this code, it's the same thing as before, just a placeholder and put this over here. But it also included that class level attribute birthplace. When you create Woody, in this case, nothing specifically on Woody says what his birthplace is. When I create Picky, same thing here. That character instance gets created. Nothing specific. Nothing there says it's his birthplace. But Woody can access it. So if I say Woody.birthplace, the interpreter says, wait a minute, I don't have anything here unique to my instance. I will look on the character class. Okay, there's something there, I'll use it. So it prints it out. Same thing with Picky. Now, let's say I'm sort of changing my video game and everybody automatically is going to be portaled to another kingdom, right? Well, then here, I can change it at the character level. I can say character birthplace is Narnia. So now I change it at the class level. If I look at Picky's now, if I look at Woody's, oh, sorry, I skipped one. I skipped 13 here, pardon me. Picky set his own. Let me go back to that. So Woody's was the kingdom, and then Picky changed his. So Picky changed his, and it got set on the instance. So now, when I change it on the core character class, Woody still doesn't have a birthplace, so he's going to rely on that one. But Picky's has his own special one. So he doesn't have to go back to that class to get a value. So these links are in here. I get used to playing with this a little bit. Use this Python tutor site, like with your assignments and stuff, if you're confused as to when and what's going out of scope, specifically with those attributes. This would be pretty helpful. Okay, common mistakes. This is the danger of using these interpreted languages rather than compiled languages. This code, you could be running hundreds, thousands of lines of code. Until it hits this line of code, it's not going to like blow up on you. So here it's going to blow up because if you remember back to our character definition, we didn't give them an age, right? So I can't access the age. It just doesn't exist. Sort of same thing with the instance attributes versus class level attributes. We gave characters names, but the character class itself doesn't have a name. So you have to be careful. You can't say like character.name. If you think about it, it doesn't really make sense. Like an instance of a character has a name, but not character itself. Okay, so let's flip metaphors again. Our restaurant has different menus for breakfast, lunch, and dinner. However, some things are in common, like the tax rate and the employee discount for meals. So, oh, and it's also good to know the total number of items on all the menus. So I've copied over here, I've copied over here what we did in that first section. I have my menu items, right? Same thing. Then I have the menu. I think the print menu probably looks a little different. And I built out a whole bunch of menus. Here's a breakfast menu, a lunch menu, and a dinner menu. So if I run that up, you get a pretty nice looking menu there. Let's enhance this. Let's add some class level attributes. I'm going to create these here. Tax rate, employee discount, total items. Might want to pay attention to this a bit. This is pretty much, the assignment's going to be very similar to this. So if you're doing the assignment, don't forget to refer back to this good stuff. So I'm going to create tax rate, say 7%, right? So not like the restaurant's going to move jurisdiction. So tax is 7%, employees get a 50% discount, and the total number of items is 0. So what I'm going to do is every time I construct, oh, and sorry, I don't want these on menu item. Pardon me. I want these on the menu. So every time I create a menu, right, I'm going to increment this. I'm going to say self.total items plus equal the length of the number of items that I added. I have a couple choices here. I could do that. Typically, when I'm dealing with class level attributes, I use the class name. It's just easier. There's no confusion if somebody accidentally decides to create that instance level attribute somewhere else. So here, you can probably see this growing, right? I can say print menu dot total items. So that's my first one. This is after I create a lunch menu. This is after I create a dinner menu. So notice here, when I created the first menu, the breakfast menu, I only had 3 items in total. But I created another menu, created a lunch menu. Now in total, I have 6. And I created another one, a dinner menu. Now I have 9, right? And what's the last part of this? Update menu print to indicate n out of total items. Print out the price with and without the tax. Okay. So let's say here, let's create our new title message. And we're going to say that that's going to be self.name. And then I guess I'll do a parentheses. And now how many items do I have? Well, this thing has length menu items over menu dot, what did I call it? Total items. Maybe simplify this a little bit. Baby steps, just do one thing at a time. Oops, what am I missing there? So I got to close that off. Uh-oh, menu items is not defined. Let's see. Oh, because I have to do self. Self.menu items. Cool. Lunch 3 of 9 items. Dinner 3 of 9 items. Breakfast 3 of 9 items. That's cool. Now, if I want to make use of that tax thing, right? Let's change this up. Let's have a pre-tax price. So that's the item price. Let's take the post-tax price. That's the item price times menu dot tax rate plus whatever the item price was. So now here, you'd be able to say, that's my price, and then with tax, oops. So hopefully that checks out. A taco, $4.50. With tax, it's $4.82. Hot dog, $5.50. With tax, $5.88. Something like that. So that's about everything I can think of to do with attributes, class attributes, instance attributes. You have 3 examples now. You have the examples in iBooks. You have the character example in the slides, and you have the menu items here, right? And then we'll do yet another one when we get to the assignments. Okay, so if we have attributes, we already have methods, and probably don't have to do a lot on these slides because we just looked at it 100 different times. But just to drill this home once more, we declare a class. It has a docstring. We indent. We have our function. Actually, that should be indented too. We have a docstring for our function, and we use self whenever we want to do something with an attribute inside that function. Try to apply what you already know. So here's a perfect example. School. This is a string. It's an instance of a string, but upper is a class method. It's declared on the class. So it uppercases a string or it lowercases a string. We've seen it with lists. Here's grades data structure. It's a list. It has a method called append. It has a method called pop. But don't get confused, right? Stuff like length, stuff like print, stuff like input. Those aren't methods. They're functions. So we don't say something like my list.length. Might in other programming languages, but not in Python. Right? So method, when it's declared on a class. Function, when it's outside of a class, and just standalone. Okay. Just another example, because we looked at this a bunch of times already. There's my class, right? If I want to make this an interactive game where 2 characters fight, when one character fights another one, we pit their strength against their defense score. And that determines the damage, which we reduce from the health. So we could write our video game and we can do this like all over the place. But if we had to do that like 1,000 times, like if this is a game where all of our characters fight, we have hundreds of characters, it's going to get old doing that. So one option is to create a function, right? And so we can just create a function, has nothing to do with the classes themselves, and we can pass into 2 characters, and we can do that same math. Much better idea, though, is to take that and put it into our character class. Much like how I put that print menu function inside the menu, right? It's likely, without having a menu, there's no reason to have this print function. So here, probably a good idea to move that attack function inside the class for characters. And this allows me to make, some decisions I couldn't make previously. Who attacked who, right? Did Picky attack Woody or Woody attack Picky? Well, here it's pretty obvious. Woody attacked Picky. I'll just jump into Python Tutor real quick. Again, I'm really leaving this here for your reference, to use this during the assignments, use this when you're prepping for the test. This is just a more advanced example now where I'm adding in an inventory. So like in a lot of these games, characters can pick up weapons or they can pick up supplies, they pick up food, stuff like that, right? So in this particular example, just expanded out this character. I added sort of a rule here. It says, hey, a character, let's assume like the character in the game, they carry like a backpack. How many things can they carry? Well, the max things they can carry is 4. So that's declared on the character level. So when I create a character, I create Woody, goes into my constructor, the init function. Create Picky, goes into the init function. Call a method. I'm a Woody. Print out the inventory. Nobody's picked up anything. Okay, cool. Here, I have this first character. I'm going to call this store method. Well, I have this rule I said they can't have more than 4 things. So they picked up their first thing. Cool. I can grab it. Now my inventory has an apple in it. Picked up another apple. My inventory has 2 things in it. Sword. Next here, a shield. Now I'm going to pick up my 5th thing, I think. Now, too much stuff. Can't store another item. So I didn't store that thing in my inventory. If I want to, I can remove something. Okay, so I have another remove function. If this item's in my inventory, get rid of it. And then I can add something back in. All right. The methods one, this is actually pretty much what we looked at just a minute ago. It's just expanding upon that to do something with employee price. This one I'm going to leave as an exercise for y'all to look at because it's all pretty much completed. It would just be me walking through the code. I did want to save a little time today. 2 things as a reminder. Let me just flip over to this. Wednesday, no class, wellness day. Thursday, we will be doing the quiz on chapter 8, which is files. That'll be worth 80 of 100 points. Remember, I'm kind of splitting this stuff up. So we'll be taking the quiz, both of the points you can get on Thursday. On Friday, for coming to class, you get 20 points. Why is that? Based on the requests from the class, for what you want to talk about, I want to get some tech leaders in front of us. And I got some pretty heavy hitters to come talk to us. This should be a pretty awesome class. Last up, I hope you can make it. I have a 3-star general come and talk to us, Steve Hager. I know him as Steve. He works at Google. I've done a bunch of risk assessments for him. He's the Chief Information Security Officer for Google Public Cloud. So anytime Google sells to the government, the CIA, the Army, the Marines, whoever, he's the one who does it. But he was in charge of the Cyber National Mission Force. So he's an awesome guy, and he's going to talk to us a little bit about tech leadership. I also have MK Palmore come talk to us. MK serves as the director of the CISO for Google Cloud. He worked in the FBI for 22 years. So both these gentlemen worked in cybersecurity, pretty stiff stuff. So they're going to be fun to listen to. My friend Allison, she runs a division inside Google called the Google School for Leaders. So she's going to help sort of frame that whole discussion with me. And then finally, I have my friend Kobe, who's a software engineering manager. And so the way this sort of is playing out, he's got 12 years experience. He's got 22 years experience. He's got 40 some years of experience. So we should be able to get a good picture of what a tech leader looks like and sort of what lessons we can learn from them. All right. Last thing, I did want to give a special congratulations. Joel, Zaya, Samuel, you guys here? You guys come up for a second. There was a hackathon on Friday. That's why they missed class. And I want to give them a big round of applause and credit for doing a hackathon. That's like 3 months of coding experience. So keep up the good work. Things will play. Sam reminded me there is another hackathon coming up this Friday. Yes. So if anybody is interested in that, how do they sign up for that, Sam?
They have like a week.
Yeah. And real quick for the class, what was the hackathon about on Friday?
You had to make a password strength analyzer. So yeah, everyone else
the like hackathon, they were doing some crazy stuff. But we did our best and it worked. So that's what I think is most important. But, yeah.
I think it was pretty awesome to see. I mean, you up against grad students. I mean, the grad students were nuts. I mean, those guys deployed an AI-based solution in Google Cloud to check the strength of password. Like when I saw that, I was like, I have no idea how you guys did that. But please, I encourage y'all, if this is your trajectory in life, do these hackathons. It's like, hey, you win surprizes. That's kind of cool. But also, like what they were doing, I've done that probably 30 times in my career, over and over. Every different company wants some solution to check the strength, the password, the different, different characteristics of them. So anyways, congratulations. I encourage everybody, do hackathons if you can. Reminder, Wednesday we're off, Thursday quiz along with the lab. Friday, we have our leadership lecture, and we'll pick up on classes on Monday. Thanks, y'all.
Thank you.
Slideshow. Go back to my room. I got to that's my head back.